Yeah, this is super fun. How's everybody doing? I'm super excited to be here. Thank you for having me, and thank you Vishal and Laracon India team for organizing such an amazing conference. I love this conference in India. My name is Ryuta Hamasaki. I'm from Japan, and I work for Laravel, and currently I'm working for Laravel NightWatch. So today I'll be talking about working with a big Laravel application using a modular monolith architecture. My slide is not coming, but it's okay. So just a little background of this talk. I talked about modular monolith at Laracon Online before, a few years back. My talk was primarily focused on modularizing the back end of your application and didn't touch on how to modularize the front end of Laravel application. So today I'll be extending my talk to modularize a full stack inertia application. Okay, so again, I'll be talking about working with a big Laravel application with a modular monolith architecture with inertia application. So before we talk about modular monolith, let's talk about monolith. It's a default choice for most of the applications out there because it's simple. You only have one repository, single deployment pipeline, simple infrastructure. It's easy to handle database transactions. It's also easy to debug and test. It works pretty well when your application is small, but you might face some challenges as your application grows. There are no boundaries between different functionalities in your code base, and they are tightly coupled. You can call anything from anywhere, and when you change feature A, you break feature B. And it's also a challenge to onboard a new developer because there are so many files in a massive code base with no boundaries, and it's hard to understand. And microservices emerged to address those challenges. In microservices, your application is divided into small applications or services, and each service has its own database. The services talk to each other through a network call. The good thing about the microservices is that there are well-defined boundaries between the services, and teams can work on different services without affecting each other, and services can be deployed and scaled independently. When service A is down, you can still use the rest of the services. But it's going to introduce a lot of complexities to your application. You'd have to manage multiple different repositories, multiple deployment pipelines. Infrastructure is going to be way more complex, and you need an orchestrator like Kubernetes. There's a network overhead when services talk to each other. It's also challenging to ensure data consistencies across the services because you cannot use database transactions between services where the databases are physically separated. It's also hard to debug and test. So modular monolith is a good middle ground between monolith and microservices. It's a monolithic application that enforces strict boundaries between different functionalities, but keeps everything in a single code base. It's the best of both worlds with the simplicity of monolith and well-defined boundaries of microservices. You still have only one repository, single deployment pipeline, infrastructure is still simple. You can also use database transactions across the modules, but there are well-defined boundaries between the different features within a single code base. So in modular monolith, your application is divided into multiple modules based on the features or business domains. And there is usually one database in the main application. And each module is like a mini Laravel application that contains everything you need, such as controllers, routes, models, database migrations, tests, and even front-end code. The modules talk to each other via public APIs, such as contracts or events, which I'll cover later. It's basically applying modular microservices mindset into a monolith. You can also extract a module to your standalone service if you want to, and it allows you to incrementally migrate from a monolith to a microservices. And modules talk to each other through a contract, which is basically a PHP interface that defines the expected input and output of the method. And the good thing about the contract is that it encapsulates all the implementation details of a module. And when module A talks to module B, it doesn't have to know how module B works under the hood. It just needs to know what data to send and what to expect back. And teams can work on different modules in parallel as long as they follow the contract. It also makes testing much easier because when you're testing module A, you can mock the contracts of other modules, and you can focus on writing the test of the logic that you are actually testing. Modules also communicate via events. When something happens in module A, it fires an event, and other modules listen to it and do something on it. And module A doesn't have to know how other modules listen to the event and how it handles the event. And in microservices, you need a separate event bus or event stream, such as Apache Kafka. But with module monoliths, you can just use Laravel's native event system, which is much simpler. So it sounds like a very solid architecture, but it's not for everyone. You shouldn't use module monoliths for simple or small apps. It's just over-engineering. So I recommend that you always start with a monolith, and you can always incrementally migrate to modular monoliths if your application grows to a point where you start to feel the pain of a monolith. So who uses modular monoliths? Shopify is one of the largest Rails applications out there. They incrementally migrated their massive code base to a modular monolith, which gave them the structure they need while avoiding the complexity of microservices. GitLab also uses modular monoliths for their main application, which is also a massive code base with over 2 million lines of Ruby code, where over 100 developers are contributing to it every day. And what about the Laravel community? ASICS uses Laravel and modular monoliths for their B2B product, where almost every ASICS product is sold to their resellers worldwide. And ePark is one of the largest mobile packing apps in Sweden. They also use Laravel and modular monoliths for their application, which is used by 2 million users. And who else? I asked on Twitter because I was very curious. And I got a lot of responses, and it seems like a lot of people are using modular monoliths for their Laravel applications in production, and it's working pretty well for them. So I can say that it's a valid solution for many organizations and teams. But it's still not perfect. Any technical decision comes with some trade-offs. And in modular monoliths, there's some performance overhead to cross-module data retrieval. What I mean is that when module A retrieves some data from module B, it cannot use model eagle loading in Laravel. So instead, you have to use the contract that the module B provides to keep the modules isolated and decoupled. It's fine in many cases, but if you experience any significant latencies because of this, what you can do with the Inertia application is that you can use deferred props, which was introduced in Inertia 2.0. It allows you to immediately render the component, and then asynchronously fetches the data in the background. And you can show the loading state while Inertia is retrieving data. You can also prefetch an entire page even before the user visits the page, which also improves the performance. Another trade-off is that modules cannot be deployed and scaled independently. A modular monolith is still a monolithic application, and everything is deployed as a single unit. And if you require more resources for a specific module, what you can do is that you can configure your load balancer to route the specific, the module-specific traffic to a dedicated group of servers, so that you can control the number of servers or server resources for each module. Okay, let's talk about code organization. In a typical Laravel application, your code is organized around technical concerns such as controllers or routes or models. And everything is in the app folder, and all the controllers and models live in the same place with no boundaries. In a modular application, your code is organized around business concerns rather than technical concerns. And in this example, you can see app modules folder with some modules such as booking, check-in, and whatnot. By the way, you can name it whatever you want. It doesn't have to be app module, but I personally like this pattern because it appears right below the app folder. And yes, you still have the app folder, and you can keep the global or common files, such as user model or some auth-related stuff, which is kind of global. Let's look into one of the modules here. And each module is like a mini Laravel application that contains everything it needs, such as config, database migrations, or front-end resources, and routes. And here, source folder is equivalent to the app folder, which contains files such as controllers or models. And in this example, it follows Laravel's conventional folder structure, but you can go with a fully custom structure if you want to. By default, you register modules by creating a service provider in the module, and you register your modules, routes, database migrations, and views, events, everything manually, which is fine, but there will be a lot of boilerplate code as your application grows. So here's a handy package called Modular, which was created by Chris Morel. What it does is it automatically registers all your modules so that you don't have to manually register all your modules, stuff such as routes or database migrations. It also provides a handy command to scaffold a new command in your application. So what about the front end? How can you modularize the Inertia front end? By default, Inertia renders the components from the default folder, which is resources, JS pages folder, and it doesn't understand the modules. So we need to do something on it to make it module aware. And in the Laravel application, Laravel backend controller, this is how we usually render Inertia components. In this example, the booking passenger controller lives in the booking module, and it renders the passenger create component, which also lives in the booking module. But again, Inertia has no ideas about it and cannot render the component. And we can add a module prefix to the component path, but Inertia still doesn't understand it. So we need to do something on the front end as well. And this is the entry point file to the Inertia application, which has the resolve function. It renders the Inertia component from the default folder. So we need to update this function to make it understand the modules. And this is the updated version of the function. Basically, if the name, component name includes the module prefix, it splits the module, the name into a module and page. It renders the component from the modules folder. Otherwise, it falls back to the default folder and render the Inertia component. We also need to update one more file, which is the app.blade file. It's an entry point to the application, and it specifies the Inertia entry point file, app.tsx, as well as the page component for the initial page load. So we can do pretty much the same thing. So if the component name includes the module prefix, renders the component from the module, otherwise fall back to the default folder. So now we are ready to develop a modular Inertia application. So let's look at some real application. So I created a demo application called Artisan Airlines. What you can do here is that you can search for flights and book a flight by providing passenger information and selecting a seat and providing payment details. So this is a very simplified version of the flight application. And I just said that you shouldn't use modular monoliths for simple applications. So in reality, it doesn't make sense to use modular monoliths for this, but I think a real flight application is super complex, and I think this is a good example to demonstrate how to modularize an Inertia application. And this application has 4 modules. The flight module handles flight scheduling and airport information, seat availability or aircraft information, and booking information. Booking module handles the booking of the flight, passenger details or cancellation of the flights and change of the flight as well. And the payment module also handles the payment and refund. The check-in module handles the check-in or sending check-in reminder or generating boarding pass. So let's look at a real code, some code. I'm going to stop presenting my slides and go to the editor. So here you can see the app modules folder here, and there are some modules: booking, checking, flight, payment. And by the way, this application was created by the React starter kit that Josh just presented earlier. So this is an amazing starter kit that allows you to get started with a new Laravel application with a modern front-end stack, such as Inertia, React, TypeScript, Tailwind, and Shoutsing UI. So you should check it out. And again, you still have the app folder, and you can keep the global or common files, such as user model, or some also related controllers. And let's look at the booking module here. Each module is like a mini Laravel application, so it has its own database migrations or factories. It has its own components, front-end components, inertia components, stuff like that. And it has its own routes, module-specific routes. The source folder is equivalent to the app folder, which contains the controllers or models and whatnot. A module has its own unit test or feature test. And in the project root, you still have the default resources folder where you can keep the global or common UI components. And most of the components here came with the starter kit, and all the components under the UI folder is the one created by Shoutsing UI, and these are fully customizable because they're built with the Inertia, Tailwind, and some headless UI components. So now I'm gonna run this application by running composer dev command, and I'm gonna access this URL. Cool. So this is Artisan Airlines website. By the way, this beautiful UI was created by my colleague, Jeremy. He's an amazing designer at Laravel NightWatch team. He also designed all the cool NightWatch UI. So this is in the flight module, and here you can search for your flights. So now I'm gonna search for my flights, so I can go back to Japan from Ahmedabad. So I'm gonna fly from Ahmedabad to Tokyo, and I'll be leaving on Tuesday, and just myself, search. Okay, let me make it a little bit bigger. So now we've got 2 flights. By the way, there's actually no direct flight from Ahmedabad to Tokyo, but it seems like Artisan Airlines have some special routes. So I'm gonna go with the first one for now. Okay, so now we moved from the flight module to booking module. So what happened is that when I click on the button, it sent the flight ID to the route in the booking module. And the booking module created a pending booking for this flight ID, and then redirect it to this page. And here you can see some flight details on the header, but booking module has no ideas about the flight details because this information is handled by the flight module. So let's look at how it works under the hood. So I'm gonna open the booking passenger controller and create method. Okay, so in this method, it retrieves the flight data using the flight repository, which is the contract defined in the flight module. So I'm gonna open this file. So again, contract is basically a PHP interface, and this interface has the find method with flight ID and returns the flight object. And here, this flight object or class is not an eloquent model, but this is a data transfer object or a DTO. And the DTO is a simple data container to transfer data from one place to another place in your system. The reason why we return DTOs here is that if you return a eloquent model, you end up exposing the implementation details or database details of your module to other modules. And other modules can do whatever they want, such as creating a new flight or deleting or updating the flights. So we return DTO to keep the modules decoupled. And if I open this DTO, it's just a simple data container class with some properties, but it has no behaviors or method. Cool. So this is how modules communicate with each other through a contract, and this is how we render the inertia component in the booking module with the booking prefix. It passes the booking and flight data as props, and of course this component lives in the booking module itself. It's in the passengers create. This is a React component that receives the booking flight props. It just renders the form. So now I'm going to move on by providing my passenger information and proceed to seat selection. So we are still in the booking module. Nothing interesting in terms of implementation, but I'm going to just book my seat. And I always go with the back seat on the aisle because there's a higher chance that no one comes to next to me. It actually works many times for me, so you can just try it. It works many times for me. Yeah. Cool, so I'm gonna continue with this seat. And then now I'm on the payment details page, which is the last page in the booking module. So now I'm going to provide my credit card details here. You can feel free to steal it. I'm sure it works. Yeah, you can just take a screenshot. I'm going to pay $224, and it's now processing. So now I can fly back to Japan. So thank you. Let's look at what happened behind the scenes. So when I clicked on Pay button, it called the controller in the booking module called Booking Payment Controller, the store method. So in the database transaction, we secure the seat first because someone else might be booking my seat, and so we need to make sure that we secure the seat first. But again, the booking module has no ideas about how to update the seat availability because it's handled by the flight module. So here we're calling the seat repository. This is also a contract defined in the flight module. It has a mark as booked method receiving seat ID. And if the seat is already booked by someone else, it throws an exception. So here we don't really care about the actual implementation class because we're now focused on the booking module. And after that, update the booking status to be confirmed, and then make a payment by calling the payment process method. And this payment, this is an interface defined in the payment module. It has a process method with the booking ID and amount and token. Token is something like usually a payment provider provides you so that we don't have to process the credit card details in our own server. So if the payment fails, it throws a payment exception. Yep, and there are two try-catch blocks. When seat unavailable exception happens, all the database transactions will be rolled back. And so in the modular monolith, you can still use the database transactions across the modules normally because it's a monolithic application. If it's in microservices, it's going to be way more complex to roll back all the transactions across the services. And after that, just redirect to the seat selection page. And if something else happens, which is most likely the payment exception, we catch the exception and report the exception to NightWatch. And yes, you can handle the exception, and you can still report it to NightWatch if you want to. It's a handy method that NightWatch package provides. And after that, redirect to the payment details page to retry the payment. And if everything goes well, it fires a booking confirmed event and redirect to the success page. And here it fires an event. And there's another module that listens to this event and handles it. So let's take a look at it. So I've got this event listener called create check-in reminder. It's in the booking module, check-in module. It listens to the booking confirmed event and creates a check-in reminder record in the database so that we can send out a check-in reminder to you before your, 3 days before your flight. And maybe you can create a schedule task in the check-in module itself so that you can actually send out the email 3 days before. So this is how you implement cross-module communication using the contracts and events. And there's one thing I just wanted to mention about the payment contract. So in the payment module, I've got this payment service provider. This is how we bind the contract to actual implementation. And in this demo application, I bind the contract to fake payment service. It just sleeps for 3 seconds and creates a fake payment date record and returns a payment ID. So this allows the teams to work on different modules in parallel, while the payment team is still working on the payment module. The booking teams can still, go move forward with the implementation. And once the implementation is done, we can switch it to the real payment implementation. Cool. So now let's look at how to test this controller, actually. So I'm going to open the booking payment controller test and make it side by side. Okay, so never mind. The screen is a bit too small. So I've got 3 test cases here, 1 happy pass and 2 unhappy pass. So let's look at the happy pass first. So here we're gonna fake the event first because when we're testing the booking module, we don't really care about how other modules handles the event. We just care about that the event is actually fired. And we're gonna create a fake booking data using the factory and mock the contracts of other modules such as seat repository and payment contracts and make our request to the route here. And we're going to make sure that it redirects to the success page. And we also make sure that the booking status is updated to confirmed. And lastly, we make sure that the booking confirmed event has been dispatched for this specific booking ID. So it's quite straightforward to test the cross-module communication using the mock. And now let's look at one of the unhappy paths as well. Again, we fake the event and create the booking data and mock the contracts. And this time, we mock the payment contract to throw the payment exception to test the unhappy path. So this unhappy path is where the payment fails and it rolls back the transaction and redirect to the payment page. So after mocking the contract, make a request to the route, and we make sure that it redirects to the payment page with this error message. And we also make sure that the database is rolled back and booking status is still pending. And we check that the booking confirmed event is not dispatched. So now we looked at how to implement the cross-module communications and how to test it. But you might be wondering how to enforce those boundaries between the modules, because you can still call the actual implementation classes of other modules if you want to. And for this, we can use pest architecture testing that Nuno mentioned yesterday. So let's look at how to do that. So in the flight module, I've got this architecture test. And basically, we expect that any classes in the flight module should only be used by the flight module itself, except for contracts, DTO, events, enums, or exceptions, which are the public APIs exposed to other modules. And now I'm going to run the test. Here, composer test. Now all tests are passing. So now let me make it fail by by calling the actual implementation without calling the contract. And so here, instead of calling the flight repository, I'm gonna call the flight model directly, which crosses the boundaries. And I'm gonna run the test again. So now the test has failed, saying that the flight model shouldn't be used on the booking payment controller because it violates the boundaries. So, and I'm gonna revert it back and run the test again. And now it's passing. So this way you can programmatically enforce the boundaries across, between the modules. So whenever you cross these boundaries, your test failed and your CI failed, and you cannot deploy it to production. So it's pretty straightforward to enforce those domain boundaries and test it. And that's all I have today. And I couldn't cover everything I had within the 30 minutes. So if you want to learn more about module monoliths, there's a great course on Laracast by my friend Matthias. My previous Laracon talk is also available on YouTube, where I covered how to modularize your Laravel application without using the package. You can also scan the QR code to find out some of more useful resources, including the code base of the Artisan Airlines repository. And I hope that this talk gives you some ideas about how to work with a big Laravel application. And thank you very much.
All right, thank you. So you have more than 50 questions.
Wow.
Yeah, all different type of questions. So you go through them and then give an answer. So before that, do we have Preksha Shah here? Where are you, Preksha Shah? Yeah, you can come near the stage. So out of all questions, one of the interesting question is about, they say that Japan is all about cars. And also especially modify cars. So they want to know, like, are you also in love with cars or do you like cars?
Actually, I don't own any cars because I live in the city and I don't actually need cars and I can always rent a car. And actually, I just got my driving license just a few years back. So yeah.
You want to drive in India?
Yeah, hopefully, yeah, next time. Yeah.
Not this time.
Not this time.
That means next time you are not coming if you want to drive. But he's saying that he loved the Toyota Supra car sound. Where is Meet? Meet, where are you? Yeah, here. How does it sound? No, but just make a sound so we feel the sound. No, but your voice is more than a speaker. How about he make the sound of the car on his own, right? Just make the sound. Huh? Arey, just stand up, bro. Ishq hai to risk hai, risk hai to ishq hai. So just make the sound of the car. How does it sound? Tu 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 tu. Have you ever heard that sound?
Yeah.
Like, tu 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 tu.
Yeah, maybe something different.
I'm glad that sound doesn't happen in India. Otherwise, all the street dogs will come after. All right. So the question from Preksha is, how can you modularize a Laravel application with Inertia.js with ensuring scalability, separation of concerns, and efficient state management?
Okay, so I think scalability means some different things. Like it could mean scaling the servers and infrastructures, or scaling and maintaining, the code base and teams. So I think in terms of the infrastructure, I think I covered it in my talk. But so by default, everything is deployed as a single unit. But if you want to, you can still configure. Maybe you can allocate a dedicated server resources for each module, and you can configure your load balancer to route the module-specific traffic to different group of servers, and it's going to complicate your application a little bit, but it's still feasible. And in terms of working with many teams, basically each team should own one or more modules, but the same module shouldn't be shared by multiple different teams because there'll be a lot of conflicts. Yeah.
Yeah, thank you.